Hello everyone, welcome back. I hope you had a great lunch. Welcome with me here on stage from the beautiful country of Switzerland, Stefan Eichenberger, whom I have known for quite a few years. At least we met a couple of times at various conferences, and he is going to talk about a topic that is actually pretty close to my heart, in the meaning that when we are working together with customers, oftentimes we hear their pain stories around upgrading and keeping updated their whole software landscape on embedded projects, right? And hopefully after this talk, Stefan will have shown us some ways out of this hell where we are tied to archaic old versions of our libraries, of our kernel, and so forth. So please give a big hand to Stefan. Welcome.
Thank you very much. Yeah, my name is Stefan. I work as a freelancer in Switzerland, Bern. I don't know if you were ever there. I have my own small company. It's a one-man company. However, before I was working for Toradex, and that's also the provider of the hardware, and that's also why I will talk about Torizon. That's just full disclosure, but it shouldn't just be for that target. So I hope you can anyways learn something. So the topic is, as said, keeping Qt-based embedded devices up to date. First, why should you care about updates? Probably you're asking, yeah, my device, I will write some code and then it does something, we will ship it to the customer and then we can forget about it. However, as you all know, software will always have bugs, so you have to fix bugs in the field. If the customer is unhappy with your product, you will probably lose him in the long term. So that's one thing. However, there are also other things like security threats that has not even to be in your own application. It can also be in a third-party component that you're using, like SSH or OpenSSL. So you have to fix these things, especially if it is connected to the world, because if it's somehow connected to the internet or to the cloud, then you definitely have to fix this. And another thing is, of course, if you plan to provide a new feature over time. So even if it's just another look, maybe it has to. The product management decides that the old look looks too old and you have to update to some new fancy layout. So that's why you have to care about updates. And by the way, sorry for probably the slides look a bit strange. It's just because the resolution does not match somehow and I cannot fix it currently. So sorry for that. One thing I will talk about, fail-safe updates. Fail-safe updates are not secure updates, so we have to differentiate here. So fail-safe means you protect your software against things that you know can happen. Like if you are updating your device, maybe you have a power loss because someone unplugs the device. If it would be a secure update, that means only a signed version of a new firmware will be installable on your device. So if your company provides an update, then the company will sign it and ship this signed version to the device, and the device can verify that it is really signed by you. I don't talk about this, however, all the things I will show you are also securable. So all of this mechanism will also support secure updates. Not all of them will support fail-safe updates, but we come to that later. And furthermore, even if you have secure update, it doesn't mean you have a secure device. I mean, you have also to lock your device against physical attacks like SSH, or if you have a TTY device open, a console, and you can just log in with root, then even if you have a secure update, the device is not secure if someone attacks it. And in a last step, even that cannot may sometimes not be enough. Maybe you also have to do secure boot, then that will be another topic. So then you have to verify the whole update chain, and then you get to a secure device, basically. What technologies will I show you today? I will start with an old, hopefully familiar one, that is packaging. So if you are familiar with Linux and you use, for example, Debian, then you use dep package. If you use Fedora, you have RPM package. That is what I mean with packaging. Then I will switch over to a well-established variant, which is partition swapping, where you just swap the boot partitions when you do an update. Then I will go further on with a more fancy approach, which is OSTree. This is a newer technology. It's also well established nowadays, but it's a little bit more modern than the partition swapping. And in the end, I will also show you a container-based approach, which is basically packaging again. So we close the loop. So we go back to packaging again. However, instead of just packaging your application, you basically package a whole distribution into a container and then ship this container to your device. I shortly want to talk also about the naming convention. I use these different terms, updatable, fail-safe, and recoverable. Updatable means you have a system which you can update. So you can replace your application with a new application. You can maybe replace a library with another version of a library. That means updatable. However, if you have a power cut during the update, you just end up with maybe a broken system, or maybe you have to recover it manually. Then fail-safe would mean that you can update your device in a way that if there is a power cut, it will continue to work. So if there is a power cut, it will reboot, and then it will just load the previous version of your software. That is fail-safe. And then furthermore, there is recoverable. Recoverable would mean that even if the update was successful, it boots into the new image, but maybe because of a misconfiguration, the application crashes, and then it would detect that this application crashed and recover back to the previous system. So here, these are the differences between fail-safe and recoverable. Recoverable would even detect the crash of the application in the field. And then you have all these things for the bootloader, and what I say here is U-boot, and then you have it also for the root file system. But normally, what I see, or what you should do is basically, if you check here, you should definitely try to achieve fail-safe. Ooh. Is that good again? Okay, perfect. You should try to achieve fail-safe, which I would call double fail-safe, which means you can replace your U-boot fail-safe as well as your root file system fail-safe, because even the bootloader has sometimes to be updatable. That can happen if you, for example, use old NAND technology because you messed up the ECC or something like that, and then you are happy if you can update it in the field. And it shouldn't break, of course. I never saw the double recoverable, to be honest. I think that's also too much maintenance effort, because you would have to kind of create a first stage bootloader which then detects that U-boot crashed and then do a fallback, and that I never saw. So what I also know, some customers use fail-safe, so fail-safe recoverable, where they have a fail-safe U-boot update and can recover a root FS. So then we are already at the first update mechanism, that is packages. As I said, you probably know that from Linux. It's what Debian uses, what Fedora uses. It's just if you type in apt-get update or apt-get dist upgrade, and if you have to switch a whole system, then basically all packages will be replaced, and that's exactly the problem. So if you update from one distribution version to the other, and you have a power cut, then normally it will not recover automatically. So you have to do some manual steps. If you're lucky, you can do some manual steps. Maybe you are in a state where you not even can access your system anymore. It is widely used for desktop applications. I don't know who of you would say he's only a desktop developer, so he never really worked with embedded devices. Okay, just one person. Do you plan to switch to an embedded device, or?
No, just this lecture seemed more interesting than the
Okay, perfect. Yeah, if you would develop for servers, maybe some of the topics are also interesting for you. If you use packages for embedded systems to do update, you just have to know if you want to do a system update, it will be probably fail at one customer. So normally that means you would have to send a service technician out there, and then he will do the update. So therefore, I would just recommend that in certain specific application where you know the updates are only installed by service technicians and not by any end customers, so that they can also do manual recovery if it is necessary. And normally I wouldn't recommend it for connected systems, because as soon as they are connected, you have to probably do whole system updates, and then it's just something that normally doesn't really work. So I will show you a first example. I wrote a small application which will basically support the next software update mechanism I will show you. This is partition swapping with SW update. The whole thing is, I can just build the application as a normal Qt application. So these are the steps I normally do. Qmake and then make. And in the end, I just have a configuration file where I can increase the version. So I did that I didn't have to recompile it all the time, and it was just easier for me. And then I use nfpm to do the packaging. nfpm, you can feed in a YAML file, and the nice thing is it can produce Debian packets, RPM packets, or APK packets for Alpine Linux, just with the same configuration file. And what it does is really simple. It just copies the application to user bin. It will install systemd services and a simple config file, which is the version, and then it does some post-install and pre-removal steps, but the pre-removal steps we will not see. So I will just transfer this file now to the target. So this is now the Wordin IMX8M Plus from Toradex. This is an embedded device with a boot to Qt variant installed. So what I then do is I call dpk and install the package. So currently nothing is shown. And if I now press enter, it will install the application and will show it. So that's the classic way of how you install packages. You can also do updates in the same way. Yeah, maybe you cannot see that much. So, and what will happen is just during the talk, I will increase this version number. So that's the only thing you will see. Oh, and the color also changes normally. So the next thing I would like to talk about is the partition swapping. That is something which is widely used in embedded applications like industrial devices, for routers, I think that's one of the most used update mechanisms as far as I know. There are open source implementations like swupdate or Rauk. You can also do it just with a shell script. I saw that as well. It's well suited for embedded systems, and it is fail-safe. It is fail-safe. So how it works, maybe I should first talk about that. What you have 2 copies of your root file system, your Linux file system, and you always update the inactive partition. So if you are booting into the root file system A, then you will update your new version to the root file system B, and then you reboot and just tell the bootloader it should, instead of using the root partition A, it should use root partition B. You also have normally a configuration partition. That is just that you have some persistent configuration available. And as said, this mechanism is by design fail-safe if your partition swap is atomic. So what that means, the operation which tells to swap the partition needs to be fail-safe. So if a power cut happens while you are writing, it still has to be able to boot. That's the only thing which is necessary for this mechanism. You can also make it recoverable. Recoverable would mean if you boot into the root file system B, then at one point the system crashes because you have a misconfiguration maybe, or your application has a bug which you didn't find during testing, which shouldn't happen. But then you could roll back to the old version. But instead of investing into the recoverable, better invest in testing, I guess, so that you really catch these problems before you even deliver an update. So I have also an example here. What you can see here is my little packaging mechanism so that I can show you different versions. I have a root file system which is set based on boot to Qt. Then I add just some overlays, like for the swupdate, I just add some binaries which I then merge together, and then I can easily create some new updatable files. For creating a swupdate file, which is the thing I will show you today, I just create a CPIO archive, which needs to include a software description file, then your root file system, in my example as tar file, and an update script which does some pre- and post-installation scripts, and then we can just CPIO them together, and that's our swupdate file. This is just for swupdate. This is how it expects that you pack your update. Then I will show you quickly the ASV description. So the software description file just tells what version you will install, and then what compatibility it has to what hardware versions, if you want to check that as well. And it also includes the update file. So in our case, it's the image.tar.zst, which is also in the CPIO archive. And here I just unpack it to this device in the end. And which device this is done by this, or is decided by the update.sh script, which is the script which is executed before and after we install the new image. In the pre-install steps, we just try to figure out which partition is the active one, and then we make a link of the inactive one to dev update, so that swupdate afterwards knows which one it has to update. And after we succeeded with the update, we just mark the new partition as bootable, and afterwards we mark the currently active one as not bootable anymore. Here we have to be a bit careful because I use parted. The bootloader needs to support that, so it might happen that you have two bootable partitions afterwards. However, in our case, it will just take the first one, and we are still good. And this has to be the atomic operation, so this one that cannot fail, and it has really to be atomic on a hardware device level. So it, depending on what technology you are using, if it's eMMC, you have to consider what the eMMC basically will provide you, what is still atomic. So we can now run a software update. We just select this previously generated SW update file. It will now upload it. And the nice thing is it provides also a library which we can use from Qt. It's a C library where we then can ask for the current state of the update. Unfortunately, not the process of the uploading process, but afterwards we can see the installation process. We could also select the file here locally, so we can do both local updates and remote updates via browser. It will also support things like BitHawk if you want to provide your updates from a cloud. However, this is not what I show. It would support it, however. So it's now updating it, and you can see it's also updating it on the device. And you can see currently the first partition is marked as bootable. So I changed which one is currently bootable with the normal MS-DOS partition flags. So now it's the first partition. Afterwards, it has to be the second one. It will now reboot. And if you're lucky, then it should be the second partition which we are now booting from. So yeah, this is this second boot partition. We have some other options which I will not show you, which are similar to partition swapping. One is using a recovery image. That's also something, as far as I know, Android used and I think still uses. Instead of having two times a full root partition, you have the normal root partition and the smaller recovery partition, and then you boot into your recovery image, and the installation will be done within the recovery image instead of the productive system. The advantage compared to the partition swapping is that this one can be smaller, so you waste less space compared to this approach here. However, it means you have to maintain two systems because you have a recovery image and a root file system. And it's a little bit harder to handle, especially also during development, because the nice thing about partition swapping, if you're working with the root file system and you want just to replace it, you can easily do the steps manually. And here it's a bit harder because you have to do the reboot, then you have to select the right partition for the recovery image, and then there you have to install your new file system. Often for the recovery image, they use a Init RAM FS, which is just a packed RAM disk image. So it makes the whole thing compact and fast to boot. Then we're already at the next possible method we can use. We just use always an Init RAM file system or the RAM disk image. It's always a little bit mixed with Init RD, Init RAMFS. I just use them as the same. It's not exactly the same, but we will stick with that. And what we do in the Init RAMFS, we basically decide if we need to install an update or not. And if we don't need to install an update, we just boot into the final image. If we see there is an update available, we install it and then afterwards boot into the new deployed image. This is kind of a supportive method. We can see this with other methods. It's also something, for example, Ubuntu or your desktop PCs uses, however, not for updates, just to mount stuff which is not mounted automatically by the Linux kernel. This is what the Init RD or Init RAMFS can do. And it's also used by OSTree because OSTree needs to start some applications, and if you have not a valid root file system available, then you will not be able to execute them if you link dynamically. You could also link statically, then you don't have the problem. That's the next thing I will show you. That's why I mentioned OSTree. So OSTree is the first more modern approach to a software update. It's also called Git for binaries. And how it works, you have a huge repository of files which are just stored not with their file name, but with the hash of the file, .file. So you have this database here. And you put all your files in there. Then your active system is basically just an assembly of links of the files that are inside your database. So this file A is pointing to this file C, and so on. And these are hard links, so this means these files and this file is exactly the same. If you now want to update your system, so let's say we want to replace file A with a new file, then we just download the new file into our repository, and then we create a new deployment of our root file system. So this would be this here. And there we just, instead of pointing to this file, we will point to this file, and then we have a new deployment of our file system. And the really nice thing about this is it doesn't increase, or it doesn't double your disk space. It only uses more disk space for the file, for the size of the file you basically want to update. So not exactly, but almost only that. So that's a huge advantage. And it does diff updates by design. So you can also do diff updates for the other mechanism. Diff updates means you just fetch the differences between the file systems. However, there you would have to do it manually, and OSTree just gives you that, which is really nice if you have over-the-air updates, let's say somewhere outside where you have a 5G or 4G modem, and then you want to fetch the updates through this connection. Then if you would use full updates, like with Partition Swap, it would always fetch the whole system, which of course costs money and is normally also relatively slow. And here, that's also something which is kind of important for servers. So updating is not only important for embedded systems, also for servers, and that's why this technology is a little bit driven by Red Hat, because they use that for Core OS, I think it's called, Project Atomic, where they integrate it into RPM. So they basically use a combination of RPM and OSTree, which is called RPM OSTree, to do fail-safe package management. And this technology is also used by Qt over-the-air update, which is a part of Qt for device creation, only up to 5.15. I think they didn't really integrate it into Qt 6 yet. However, you can do it manually. It's not too much work. I did it. I will show you that. And It's just replacing a few things. And it's also used for Torizon as the core OS update that I will show you later. So I have first to start the update because it takes a bit. I know it messed up my screen. Luckily, this should be the last time we will use that. So it's this one. So what I do now is I install the OSTree version, and I use for that again SW update. And while updating, I show you the differences. So there is a script which is provided by Qt. This is this Qt OSTree script, which is part of the Qt OTA repository. I modified it slightly. What it does, it takes a boot to Qt image and then will do user merge. What that means, it puts all libraries under user lib and all binaries under user bin. And then it does a few other things so that it's in the right layout so that you can use OSTree, because it needs some specific things. Afterwards, it will create a first version, so it will take this resulting root file system and commit it to OSTree, and from that it will then deploy a first version which we can install on the system. So I talked about this repository. The whole thing is it's a bit more complicated, I would say, than partition swapping, because of this whole repository thing, but in the end it works quite well. I talked before about this hash file, so this is our repository, and they are just stored under objects, and they use a mechanism to find the files faster based on the hash of the file. That's what you see here. And this numbers plus .file are basically your files which are then on the target. And when you deploy a new version, you just create hard links to these files. So they are not copied, they are just hard linked. And that's the beauty of OSTree. It can also create you a repository for a remote server, which is what I show you here. In that case, they have an ending with .filesat. That just means they are zipped so that they are smaller. What OSTree does then is it will fetch the file, unzip it, and then store it again in the repository. And it will only use this unzipped files because it doesn't make sense. You cannot make a hard link to a zipped file, then it would not be executable. So this is the application. You cannot see it, unfortunately, that well. And I figured out I didn't connect my mouse, so I have to do that. So I think it's not, no, it is not blockable. So this is the Qt application, which is just available on code.qt. I now start here a file server. It just uses HTTP. And what it can do now is here, it can tell OSTree to fetch the data from the OSTree repo. Now we can see here, you unfortunately don't see it very well, but here it would say it is a new version available with a revision, and this revision is again available here. Now we can see it here better. So this is the revision. That's your deployed your deployment of the repository. So on my slides, this would be this new deployment here. And it just has a hash again as a revision version. So I switch now over and say update. And now the nice thing is it will just fetch what has changed. So these are not that many files, and the update already finished. Unfortunately, I didn't implement reboot, but we can now see that we have, this is the old version here, and we updated to the new version. However, the update is pending, so if we do a reboot, it should now deploy the new version, or it should boot into the new version. It is already deployed. So you can now see it is deployed, and the nice thing is it would also allow us to do a rollback. So we still have the previous version installed. It's just here under OSTree deploy. We have the two root file systems fully deployed, but we don't use double the space. That's the nice thing again. Okay, then we are already at the last update mechanism I would like to show you. We are kind of going back to packaging. It's the container-based approach. I would say this is kind of update as a service, because what all these providers of such functionality, like Toradex with Torizon, Balena with Balena, Foundry.io with their solution, and Pantacore do, they provide you a host system which they care about, how they update it, they make it fail-safe, and then you can just package your application into a container and ship this container to the device, the embedded device. And they take care that these things happen fail-safe. You don't have to really worry about it. It's really nice if you want to do fleet management. We will see that as well later. And normally they take care about fail safety and sometimes even about recoverable. Because as long as your container runtime, this thing here, is still running, you will always be able to recover your system. Because this, and if, that's also if they are able to do fail-safe updates. However, that's why you use these mechanisms, basically. So let's go to this one. So that's the Torizon thing. What I did for that, I just took my boot2Qt image, which I used before, and wrote a Docker file which uses this container image, and there I replaced the version. That's all what I do. And Torizon then wants to have a Docker compose file where you say what exact version you want to install. So here I would want to install Ampere as double update the version 6. Then what volumes you want to mount. That's just something you have to consider. You have two file systems available. So you have basically this one here, and inside the container you have again a full-blown file system. These are the mounting points and things like temp, then the GPU stuff, so that you have GPU acceleration inside the container, and you have to modify some C groups, but that's it. You upload that to the Torizon platform. First, I need to boot into Torizon. What I did, I use the config partition as my Torizon partition so that I can easily swap to that. So now it should basically reboot into Torizon. Yep. And the Torizon platform, unfortunately, we cannot see it that well because, again, of the size of the screen, but it shows you the devices which are connected. I currently only have one device available, and now I can just tell it to update to a new version. We have here version 5. That's a new caller plus a new number, and we want to update it to 6. So what we do is we just select. I pre-uploaded these things. This is the Docker file I showed you, that Docker compose file I showed you before. We select a new version. Here I have to select it. So continue. And then we say finish. It first queues it, and then Torizon will poll the server and asks, is there a new version? Is there a new version? Normally, I think it's every 5 minutes, but I increased the timing a bit so that it doesn't take that long. Yep. So the update is now in progress, and we have updated it to version 6. The nice thing, if you use Docker, it also does diff updates because it has this layering idea, and therefore, if you do an update, it just fetches again the differences between the file systems. And one thing is also, you could also use it for offline updates. There is this logbook mechanism, so you could just create a USB stick where you install the stuff and the new version, and then it will install that version. What else? Yeah, and these updates are secure. That's also something because as I first said, I don't show you secure updates, but because we had to do a deployment step in the beginning, which I didn't show you, but you have to pair your device with the cloud. There they exchange some certificates, and therefore the updates are secure. That's the difference between to the other systems I showed you. Then what is the outcome of this whole presentation? So where should you use packages? The best thing is don't use them for embedded devices. If you want to use them anyways, then really only use them in fields where you know you only want to replace the application and you don't want to do full system updates. And if you normally know that it's a service technician which will install it, so that can be a device which is not connected to the internet, and someone will go to the device and just do some manual steps. Then Partition Swap and OSTree, they are kind of comparable. They are both fail-safe and they work both very well. The nice thing about OSTree is you don't have to think about the partitioning it in advance, because you can basically use the full partition for the root file system, the config file system, and everything else. So that gives you a little bit of flexibility. Besides that, they are really similar in terms of features. It's not that the mechanisms are completely different. And the container things are really nice if you want to have fleet management, and if you have different teams caring about different things, like if you have a BSP team which just wants to develop your core OS, and then you have a lot of teams which just consume your BSP and your hardware in big companies, then they can just provide you the right containers and you can do a separation between these teams. Also, if you are a small company and you just don't want to care about software updates and just want to leave it to another company, then of course this is also a great way how you can achieve it. But it takes away a little bit of flexibility. Okay, then I'm already at the end. Do you have any questions? Most stuff is uploaded either to GitHub or to my website. You can also find some stuff on the Toradex developer site or the QtOTA update, which I used as the third mechanism I showed, is available on code.qt.io.
Many thanks already. Are there any questions? Back in the back. And please remember, put up the mic close to your mouth so we can record you.
I have a question regarding OSTree update. I understood you're changing hard links. Why was a reboot required?
Because you want to boot into your new system. So the links, now I'm not in there, but I can just mount it. It's Torizon. Yeah, they added, oh no, I mounted the wrong one. So what OSTree, when you do the deploy, what it creates for you is this second directory, which then contains your new version. So it would be this C1, and you have to boot into this, because this is kind of your new root file system, but it's just there as a directory, and OSTree deployed it there. That's why you have to reboot, so that OSTree can then boot into the new version. It doesn't modify the previous version. It will just leave that untouched so that you can also do a recovery. That's why I did the reboot.
Thank you. One more question. There's a question here.
So what happens to the old version? Is it automatically replaced with the new version as soon as the update is successful? Or?
No, it will keep the old version. So it would still be the. We almost don't see it. So it is still this 7,000, 7 something. This is the old version, and it will keep it. It will even if you download, let's say, or deploy 1,000 versions, it will keep this 1,000 versions. However, you can say, I want to remove all the previous versions up to this date or this revision, basically. So you would have to manually clean. It doesn't automatically, because you want to do rollbacks. Maybe that's the way you keep them. At least one revision you normally keep. That's also what Torizon does. It will always keep the previous version so that they can roll back if the system wouldn't come up anymore.
Thank you.
Okay.
There's another one here in front or in the back, both. Take him first.
Yeah, just a little question. You said that with the partitions, there was a method you showed after where you could store like the bootloader in the first partition, but can't you combine both? Where you have the first little partition that just boots up the Linux, and then you have your partition, the swap partitions after that?
You mean?
Yeah, with the recovery image.
This one. The recovery image. Yeah, that's true. You can even put the recovery image onto your initial root file system.
Yeah,
that's true. Yes. What you often don't, or there are reasons why you don't do it, because often you mount the root partition read only because you don't want to have it modified at all. that's one reason. And then if you want to update the recovery image, it might break. So there are reasons why you keep 2 partitions, but you are right. If you design it correctly, you can also remove it entirely. That's true. Yeah.
There was one more question here in the front.
I was wondering about the U-boot update. Like sometimes you have, hopefully not a lot, but sometimes you need to update U-boot and then it can't boot the old kernel and the other way around. Do all the mechanisms provided by default?
Yeah. Unfortunately, I didn't have the time to show you that, but what you can use, especially with eMMC, and it's highly system on chip dependent. Most modern CPUs, but I also know one that doesn't support it, so would have this boot parts. This is a eMMC feature, and you can swap them. And the SoC boot ROM will then check which one is the active one and load that U-boot. So it's kind of partition swapping, but for the U-boot. And for the Word-Dynamics 8M+, I tested it, it works well, but not all boot ROMs support it. That's a mess. And what you can do then is, if it's not supported, you have just one small SPL which will decide which U-boot it loads. But if it supports it, that's the easiest way to do it. This boot partition swap.
Thank you. No. Any other questions? I believe we still have a minute or two. If no one from the audience has a question, I have a question.
Yes.
You mentioned Delta updates,
Yes.
or diff updates. Does this also translate to Delta updates on a file base? So if I have an application with a library that is already 100 megabytes large and I only change a tiny bit?
I think there are. So normally not. So you really replace the whole file if it changed. But I think if you would create a squash FS, it could work because it's somehow. I think there are ways how you could do it, but also OSTree would just replace the whole file. It would not just fetch the diff. Yeah.
Thank you. So if that's that, please give a big hand to Stefan again. Thank you for your talk.
Thank you very much.